Hello, I'm JAGADABI Shanmukha from Sri Venkateshwara College of Engineering, and my USN number is 1V21CS062. And the subject we are going to discuss about is microcontroller and embedded system. And the topic is data processing instruction contents. We are about to discuss an overview of data processing and different operations included in it. So let's take an overview of data processing instructions. The data processing instructions cannot access data stored in memory. They operate on CPU registers and possibly intermediate data that is encoded as part of an instruction. In general, the data must first be moved from memory into a CPU register before processing can be performed. So let's simplify this. For example, you have a video in your hard disk. The processor cannot process it directly. It needs to export it to CPU through RAM, that is random access memory. Then the particular video file is processed and then it's submitted to us. So there's a lot more going in the background. Let's take a look about it. The following instructions use ALU to perform arithmetic and logical instructions. Most of them require two source operands and one destination registers. However, there are some exceptions. So let's take a look at instruction operation. So in this session, we are about to cover arithmetic, logical, data movement, comparison, and special instruction operation. So first, arithmetic operations. So arithmetic operation help in calculating data, that is add with carry, SUB subtract, SVCE subtract with carry, NEG negate, and GC negate with carry. So you can see syntax in front of you. All of the non-carry instructions involve two source operands and a destination registers. The carry instructions may only use unfinished unextended registers as operands. Here, RD is destination register and RN is the source register. So we can take a look at bitwise AND, bit clear, bitwise exclusive OR, bitwise exclusive OR not, bitwise exclusive OR, and bitwise OR not, and one's complement. So the optional S specifies whether or not the instruction should be affected in bit present state. And we have example in front of us of the same. Logical operations. We use this to perform various logical operations. And there are 7 basic logical operations involved. Those are bitwise AND, BIC, bitwise clear, EOR, bitwise exclusive OR, EOR, bitwise exclusive OR not, ORR, bitwise OR, ORN, bitwise OR not, and MVN, bitwise not. So we also have a syntax example here. The RD is the final register, RN is the present register, and we use logical operations to perform the logical calculations. The operational S specifies whether or not the instruction should affect the flag bits in the present state. We have an example here. Data movement operations. It's one of the most important operations involved. Here, the data movement operations copies data from one register to another. The move instruction is an alias chosen by the assembler for ORR, MOVC, MOVN, or add-in instructions. Those are explained as follows: MOV, move, MOV, move Z, move wide with 0, MOVN, move wide with not, and MOVK, move wide with keep. The wide moves allows programmer to widen the 16-bit immediate value to fill a 32 or 64-bit designation register. The syntax is given in front of you. A non-pattern immediates are wide 16 bits long. Any 64-bit value can be loaded with 4 MOVK instructions. If it's a pattern, it can be done just by MOV instruction. which is an alias for ORR. We can say we have a move an immediate to destination register. In the sense, we have the particular data which we can move from one register to another register immediately. So, shift operation. The shift operations allow the programmer to shift or rotate the contents of Rn by number of bits given by the contents of Rn. There are four operations in this group. That is ASR, arithmetic shift right, LSR, logical shift right, and LSL, logical shift left, and ROR, rotate right. Some of the syntax are given on the screen. When shifting right, the programmer must decide what to do with the most significant bit. An arithmetic right shift means that a sign bit is extended to fill the upper bits, whereas a logical right shift uses zeros to fill the upper bits. The registers RM values modulus the register size 32 or 64-bit is used as the minimum amount. The ROR, rotate right, rotates n bits to the right. Those bits wrap up around are shifted into the upper bits. In the example, these instructions are redundant because the same results can be achieved with AND comparison operations. These three comparison operations update the present state flags but have no other effect. So these include CMP, compare CMM, compare negative, and TST, test bells. They each perform an arithmetic operation, but result of the operation is discarded. CMP is an alias of SUBS, CMN is an alias of ADDS, and TST is an alias of ANDS. An ARCH64 translation of the C program uses CMP instruction to test whether or not the input character is a conditional branch instruction to implement the do-while loop. See, as we can see, we have compare and set present state flags, compare negative and set present state flags, test bit and set present state flags, test equivalent and set present state flags. Special instructions. As discussed before, there are special instructions which don't fall in any of these categories. These are used to request operating system services and access advanced CPU features which are not easily accessible. These instructions count the number of leading zeros in operand register or the number of leading sign bits and stores the result in destination register, which include CLZ, count leading zeros, and CLS, count leading sign bits. These special instructions also allows programmer to access the status bit of CPSR and SPSR. We have MRS, move status to register, and MSR, move register to status, and vice versa. We do have the syntax in front. The optional condition can be any of this code specifying conditional execution. By this, we've reached the end of the video. Do leave a like and a subscribe if you feel the video is informative. Thank you.